283 in the textbook. We are still on activity 1, where we are talking about the different properties of real numbers that you can apply to geometry. Things like angles was the last video or last couple of videos. Now we're on segments. What can we do with segments? So I've got my note cards here that I've made in the previous videos. I'd encourage you to keep them handy and reference with examples. Something that you should do is start putting on the back of the note cards the pictures of the angles or the line segments that match like the addition property of equality, etc., the subtraction, the reflexive, transitive, substitution, all of those. But this video is specifically about segments. What can we do with line segments and segment addition, segment subtraction? Is there anything that we need to be concerned about as we are working through these problems? So join me on page 283. Let's get into it. I have some stuff to write with, like I've got different colored pencils, some highlighters, pens, etc., things that'll make your page and the math you're doing really stand out. Consider each diagram and write a statement that applies each property to segment measures. So the first thing we're going to do is we're going to talk about the subtraction. Well, again, segment addition postulate. We're going to talk about the subtraction property of equality, part A. So as a reminder, the subtraction property of equality says if you have two things that are equal, you can take away the same amount from them equally. So kind of like what we did on the previous page, the previous couple of videos, let's actually write a statement. Let's say, here's the two things that are equal. And if you're not sure if they should be, straight up measure them. Measure in centimeters or measure in inches, but measure them just to confirm that they are actually equal, and then make a sentence that says that. I'm going to say AB equals CD. Now, I'm not using M or the line segments. I'm going to ignore that this is the other thing. Technically, these are both referencing, I actually mean like how big is the line segment. So it's simpler maybe to write it like this. Now I'm going to subtract, I'm thinking here for a minute. That's what we did in the angle addition. I need to go actually longer. I need to include the part in the middle. So my bad, the video went to PowerPoint for a second. Okay, so since that, I'm going to say, no, actually what I want to do is AC. I want this whole line segment. I'm going to say AC equals BD. Right, so there's two line segments. They're longer than, so there's some overlap. They're longer than that. And then I'm going to say, I'm going to subtract away. I'm going to take this line segment away from both of them. It's part of both line segments. So I'm going to take away BC and take away BC. And because I'm subtracting equally from both sides, it's the same line segment taken away from both of those that are equal, then what's left must also be equal. So I wrote it a little bit out of order. I had to correct myself. This is the actual 1, 2, 3 flow for the subtraction property of equality. Put it on the back of the card. We have AC equals BD minus BC, and the rest, the leftover, is an example of the subtraction property of equality. Let's go on to the next one, reflexive property segments. Can we say something about the segment itself? Find your reflexive property note card. Maybe you do need to measure CD. I'm going to show you something that isn't exactly like, I'm looking at the book. Yeah, the book doesn't mention this, but I know this is going to happen here in a little bit. I know that if I've got CD, and there it is, start at C, go to D, you can reverse the letters, and they're equal because they're still referencing the same thing. They're referencing this line segment. So it's still reflexive because CD goes to the right, DC goes to the left, but it's covering the same distance. Reflexive property. I mean, the book wants you to write this, right? The book wants you to write the measure of CD is equal to the measure of CD. That's the book's version of the reflexive property, but I'm telling you, we're going to see this as a reason for proof eventually. Put that on the back of your card. CD equals DC. Okay, now we're on to substitution property. The substitution property says if A and B are real numbers and A equals B, then A can be substituted for B. Here's our example from the notes from before. Here we have two line segments. So I'm going to say CD is 8 inches. I mean, you got to trust me, right? That's clearly needs to be measured. But they're saying you got to trust the diagram. The diagram says this is how far they're saying it. And EF is 8 inches. So if those two things happen to be equal to the same measure, then these two things must be equal to each other. And in the substitution property, there's my example. CD equals 8. And EF equals 8. So CD equals EF. We are substituting. All right, that example, put it there. On to the transitive property. The transitive property. Transitive property says if A, B, and C, so we need three things. If A, B, and C are real numbers, then the first two are equal. A equals B. And the second two, like the second and third of them, are also equal. Then the original, the first one, and the third one must also be equal. X equals 2, Y equals 2, so X equals Y. So it's very close to our substitution property. They're very, very close. Right? But we're going to say it without measures. We're just going to say the measure of angle, no, not angle, the measure of segment MN is equal to the measure of segment WX, and the measure of WX is equal to the measure of RT, right? So it's this line segment equals that one, and then this line segment equals this one, so the measure of MN must equal that one, the measure of RT. It's like we're skipping over the part in the middle, the measure of RT. I'm going to write it really, really concisely on the transitive property note card, but that's it. That's the transitive property for segments. It actually does work. So here it is, MN equals WX, and WX equals RT, so MN equals RT. There you have it. Okay, just looking forward for a second here. Yep, we're on the next activity. This activity is done. A question for you as you go. How do the statements that you wrote for segments, all of these, how are they different or similar to the statements we wrote for angles? Go back and watch the previous video so that you can get an idea, if you haven't yet, of what you needed to write here. But how are these related? How are these angle statements related to these segment statements? Are there similarities? Are there differences? What's the structure for each of them? And have your note cards with all of the notes and information that we've added to this as we go along. Thank you for watching this video. Thank you for letting me finish activity 1 with you. We're going to pick up on activity 2 in the next video, forms of proof, and I encourage you to keep going, follow along. Thank you so much. We'll see you in the next video. Bye.